In this lesson, we are going to have an introduction to polynomials. We are going to work on section 5.3 in your textbook, which is on page 436, and we are going to do all numbers 1 through 30. First, we need to discuss what a polynomial is or isn't. Poly meaning many, nomial meaning terms, so many terms, but there are a couple of exclusions there. It is not a polynomial when you have a variable in the denominator. It is not a polynomial when you have a radical anywhere in the problem, and a radical is that square root sign. And it is not a polynomial when you have a fraction for an exponent. So let's look at numbers 1 through 8. They're asking us which expressions are polynomials. So number 1, and we're just going to look and see, does it follow any of these 3 exclusions up here? And if it doesn't, we know it's a polynomial. Well, there's no x in the denominator, there is no radical sign, and I don't see any exponents that are fractions, so we would say number 1 is a polynomial. On number 2, we know it's automatically not a polynomial because there is an x in the denominator, so we would write not a polynomial. Number 3, there are no exponents that are fractions. I don't see any radical signs, and there are no variables in the denominator, so this is a polynomial. Number 4, there's no fractions for exponents, there are no radical signs, and there's no variables in the denominator, so number 4 is a polynomial. Same for number 5. The fact that it's a positive and a negative on numbers 4 and 5 doesn't change anything. So number 5 is a polynomial. Number 6, there are no fractions that are exponents that are fractions. There is no radical sign, and then there is no variable in the denominator, so that is a polynomial. For number 7, we see there's a variable in the denominator, so we know right off the bat that this is not a polynomial. And then on number 8, there are no exponents that are fractions, there's no radical symbol, and then there's no variable in the denominator, so we would say number 8 is a polynomial. So for numbers 9 through 12, they're asking us to list the terms and the coefficients. So remember we learned in Unit 2 that terms are separated by those addition signs, and coefficients are the numbers in front of variables, okay? You will always have the same number of coefficients as you have terms. So again, coefficients are the numbers in front of your variables. You will have the same number of coefficients as you have terms. So if terms are separated by addition signs, well then we can do keep, change, opposite. So we know our two terms are 2x squared and negative 3x. Remember, when you are listing terms, you separate them by either those slash marks or the commas. And your coefficients, so the numbers in front of the x squared and the x, would be 2 and negative 3. Be careful not to forget that negative in there. On number 10, we already have that addition sign, so my terms are 5x to the third and x. And remember, we have the same number of coefficients as we have terms. So since we have 2 terms here, we're going to have 2 coefficients. So our coefficient for x to the third is 5. And there is no number written in front of the x, but we know it's understood to be a 1, so that gives me a 1 for that coefficient. Number 11, I have keep, change, opposite. So for my terms, I have 4x to the third, negative 3x, and 2. And my coefficients are 4, negative 3, and 2. You may not think that the 2 would be a coefficient, because it doesn't have a variable behind it. However, if you do not have a variable behind it, it's understood to have an x to the 0 power. So that's how it is a coefficient. It's understood to have that x to the 0 behind it. And then for number 12, your terms, well, you just have one term this time, so it's a 7x squared, and then your coefficient would be 7. So for numbers 13 through 22, they're asking us to classify each polynomial as a monomial, binomial, or trinomial where possible. A monomial is when you have a polynomial with one term. A binomial is when you have a polynomial with 2 terms. And a trinomial is when you have a polynomial with 3 terms. So here I've got a term here and a term here. So that is a binomial. On number 14, we only have one term, so that is a monomial. On number 15, I have 1, 2, 3 terms, so that is a trinomial. On number 16, there's only one term, so that is a monomial. On number 17, we have 1, 2, 3, 4. Well, they don't tell us what 4 terms is, so we would write not classified. And then on number 18, notice there's a variable down here in this denominator. If you look back at our rules for numbers 1 through 8 when we were deciding whether they were polynomials or not, you will notice that if you have a variable in the denominator, it makes it not a polynomial. So they're trying to trick us a little bit in here, so be careful. Number 19, I've got one term here, so it is a monomial. For number 20, I have 1, 2, 3, 4 terms. They don't tell us what 4 terms is, so we would write not classified. And on number 21, again, they gave us a variable in the denominator, so we would say not a polynomial. And then on number 22, we have 1, 2 terms, so it is a binomial. Remember, a monomial has 1 term, a binomial has 2 terms, and a trinomial has 3 terms. So for the final bit of this one section on the intro to polynomials, they're asking us for a couple of different things here. On numbers 23 through 30, they ask us to give them descending order, to give its degree, and identify the leading coefficient. So DO is going to stand for descending order, and that's when we have all of our exponents from the largest to smallest. That's descending orders, when your exponents are from the largest to the smallest, the way you read from left to right. So here I've got an x to the 5 and an x squared. Well, 5 is bigger than 2, so they actually already have these listed in descending order. So they want us to write 4x to the 5th minus 3x squared. Notice the difference between number 23 and numbers 9 through 12. When they were asking us to list the terms, we would actually separate them by those commas. Here they're asking us to write it in descending order. There would be no commas when you are writing it in descending order. The D stands for degree, and that is your largest exponent. So the largest exponent between 5 and 2 would be 5. And the leading coefficient is the coefficient that's in the front when in descending order. That's very important that you remember that. So again, your leading coefficient is the number that's in the very front when it's in descending order. So our leading coefficient would be 4. Okay, and moving on to number 24. Remember, if it doesn't have any variable written, it's understood to have a 0 for the exponent. So we would have the 3x to the third come first, then the 5x squared, and then our 4. So our degree is the highest exponent, so it would be 3. And the leading coefficient is the coefficient that goes in the very front when it's in descending order, so that would also be a 3. On number 25, I've got a 7, a 9, and a 3. Well, the 9 is the biggest, so this negative 5x to the 9 would go first. Then my 7x to the 7th power would go next. And then my 4x to the third would go last. So my degree is my largest exponent, so that would be 9. Leading coefficient is the coefficient that's in front when it's in descending order, so that would be negative 5. Now looking at number 26, this x is understood to have a 1. So I have an x squared, an x, and then remember that's understood to have a 0 for the exponent if it had an x to the 0. So I'm left with x squared minus x plus 4. My degree is my highest exponent, which is 2. My leading coefficient is the coefficient in front when it's in descending order, so that would be a 1. Number 27, there's only one term, so all we have to write is negative 9x. Our degree is the highest exponent, which is 1. Our leading coefficient is the coefficient in front, which is negative 9. Number 28, I've got a 17 and a 4. So they're actually already in descending order because 17 is bigger than 4. So I have an x to the 17 minus 3x to the 4th. The degree is the largest exponent, which is a 17, and my leading coefficient is always the coefficient in front when it's in descending order, so that would be a 1. So now number 29, I've got a 2, a 5, a 6, and that number by itself always goes last that we found. So my x to the 6 comes first, then my negative 3x to the 5 goes next. Sorry about all the background noise, guys. And then I have a 5x squared, and then my negative 7 is at the end. So my degree is the highest exponent, which was 6, and my leading coefficient is the number in very front when it's in descending order, so that would be an understood 1. On number 15, this is the last problem we have to work. Remember we talked about if there's no variable written, it's understood to be an x to the 0 power. So writing it in descending order, it would just be 15. My degree would be that 0, and the leading coefficient would be 15. I hope this lesson has helped you on the introduction to polynomials. I wish you the best of luck.